You are going to evaluate evidence. I'm going to give you the evidence and the hypothesis, and on a scale of 0 to 10, you're going to tell me how strong you think the evidence is for the hypothesis. Starting with, Uncle Harry. Uncle Harry's 105 years old. He's been smoking 3 packs a day since he was a fetus. Smoking's not bad for you. There's your hypothesis. Here's my question. Is Uncle Harry evidence? He is. He's a tiny little piece of evidence. He's a single point of evidence. He is what you do not want to have on your lab when you get it back. This is a big criticism in science. Why were the hydroxychloroquine studies that came out bad? They were anecdotal. They only had like 8 people that they were testing on. And then they had, 20 people, but they had no controls. But a small group isn't trustworthy. Uncle Harry is a piece of evidence. In a group of 5 smokers, he's a big piece of evidence. In a group of 500 smokers, he's a blip. Now he's going to swing your average a little bit, but he's not going to have that big an effect. This is why numbers are really important when you're running experiments. You don't run a test with 1 dog and 1 cat. You run a test with 100 dogs and 100 cats. We don't run our gasoline test on a single car. It's not Mythbusters. We run it on 100 cars. So you want your numbers to be high, and that will give you better evidence. But you don't use the word prove, because Newton was absolutely positively sure he knew exactly how gravity worked, because he had all this proof, and then Einstein comes along and goes, your numbers are good, they all work, except that's not really what's happening. And that's the one thing you never know. There may be a better explanation for all the evidence you've got. So, we got to test stuff for people, but we can't really test it on people. Very often you test stuff on mice, and because a mouse doesn't live as long as a person, they live about 3 years, people live about 75 years. You may expose them to 25 times the daily dosage to get enough exposure in their little 3-year life period to amount to a person's. And then you look for things like cancer and other sorts of things. If you do get cancer in these mice, how good is that as evidence that this thing you're testing on them is actually a cancer-causing substance in people? And keep in mind, there's no right or wrong answer to this. Is that you can just, give me the number that feels right to you on these things. Right now, people are doing phone polls for the election. And then later you'll see on the news in a survey of 1,000 likely voters. So the first thing they ask is, are you a registered voter? Are you going to vote in this election? That eliminates some of the confounding factors. This many people would vote for Trump, this many people would vote for Biden, these many people are undecided. That's evidence. It's a predictive evidence. Whose phones are ringing? Any of you getting called for political surveys? No. I did. Why did I get called and you didn't? What rang that gave me the survey? People know what a landline is? I'm old, I own a house, I got a landline. Most phone polls are done over landlines. They are getting better, or I don't know, better or worse. Some of them are being done over cell phones, but for the most part it's landlines. And who owns landlines? Old people. Old people who are settled. Is that representative of the whole electorate? Now you run into a question. Now the people that run the polls go, yeah, we've looked at the history. These are the folks that really are likely to go and vote. So we're fine with them being, old settled people. But they represent the poll like it represents everybody who's likely to vote. And it doesn't. It only represents the people who answer a landline when they call it. and are not about to eat supper, which I was last week when they called me. Does that affect the reliability? That's up to you. The sophistication of video technology has made a lot of stuff possible that wasn't possible before. Doing our bird feed experiment is going to be way easier with a bunch of video equipment than it is with a bunch of human observers. For many, many, many years, the question has been, so what's going on inside a baby's brain? They can't answer our question. How can we figure out what's going on in there? And what they decided was, with video technology, you could put them on video and track what they were looking at. How many people have heard that when you leave a room, as far as the baby's concerned, you cease to exist? Yeah, it's what they call object permanence. So babies don't have that. They don't know you're there if you're gone. Something disappears from their view. They don't know that it still exists. They ran a test, got these babies in this room, and across the room is a wall with windows in it, soundproof. And windows there, windows there, windows down there, windows down. And so they've got the babies sitting, they got the video cameras on them. And what they had was a train. Little toy train comes through the window, and just before it hits the end of the window, you see it do that. And completely disappear. And rather than just lose interest and look, randomly away, the babies immediately look at the next window, expecting the train to reappear. And you can track how long they will look at something as an issue of did they get what they expected, did they not get what they expected? And if the train appears in the upper window instead, they stare at that window for a really long time. If it winds up in the window they expected, they look at it and then they kind of look away. Here's one of the first experiments they ran like this. Can babies do math? So one by one, you have a baby come in, it's sitting on mom's lap, it's got a little toy. Researcher comes in, he's got a toy like the baby has, but the baby's got the toy, so. And they go, look baby, a toy, set it on the table. Look baby, another toy, set it on the table. 2 toys on the table, screen goes up. They come in, look baby, a toy, and they set it behind the screen. Now you would expect there to be 3 toys back there because there were 2 and you just added 1. The question is, do the babies expect there to be 3? How do we test that? We have somebody behind the table that can move things on and off that the baby doesn't know is there. So the screen goes down and there's 4 toys on. The babies stare about 4 times longer than if there were 3. Screen goes down, there's only 2 down. They notice. Is it up to about 5? Any sort of math manipulation that involves up to about 5 total objects. If the number that's on the table when the screen goes down doesn't match what you showed them, you put 4 down, the screen goes up and you take 2 out, and it goes down and there's still 4 there, they stare way longer. Now that's their measurement. How long do they look at something on the assumption that the unexpected makes them look longer? How good is that evidence? Become the whole basis for a type of science thing. Now some of these are first part, second part, so you gotta give me a number as we go along. So PTA meeting with a bunch of mothers. One mother goes, gee, the kid on the house behind me has just been diagnosed with this weird cancer I never heard of. And another mother goes, my son had that. Somebody else goes, yeah, my neighbor's got that. They go, is this a thing? And they started to ask around, and it seemed like for a cancer nobody had heard of, there were a lot of cases of this particular cancer in kids. There was a nuclear power plant in the middle of this county in Connecticut. Cancer, radiation, connection. What's also in Connecticut is Yale School of Public Health. So they went to one of the professors at the School of Public Health and said, we are scared that this power plant is poisoning our kids, giving them cancer. Could you look into this? And he went, okay, I'll look into this. Now being professor in the School of Public Health gives you access to a lot of information that you can't necessarily get otherwise. So he could get into the hospital records And he goes, okay, what's my variable here? Well, they think it's the nuclear power plant. I need another county without a nuclear power plant that is comparable in population and what they call socioeconomic levels and how many factories there. I'll find another Connecticut county to compare it to that I think is pretty comparable. It's also got a hospital. I can track it. Nuclear power plant has been running for about 15 years. When he went 10 years back in the records, in his study county, the levels of this cancer were way higher than the levels in his control group. So how good is that for evidence that the nuclear power plant was a problem, was causing cancers? That's the number you're putting down for this one. Now, being a good little researcher, he dug deeper. He went farther and farther and farther back. Is that the hospital records in the one county went back into about the 1940s, the other one went back in about the 1930s. But it turns out, as far back as he could go, this weird cancer was more common in the county that eventually had a nuclear power plant. But even 20 years before the power plant was built, the levels were way higher in this county. So now how good is the evidence that the power plant is to blame? And this happens a lot where new data comes up and you go, okay, I guess this doesn't make any sense anymore. Another thing you see on the news is that they'll do public opinion polls. 85% of people believe this, 75% of people believe this, 3% of people believe this. How good is that as evidence of whatever it is that the people believe? That one, I can't give you an example because any kind of example I give you would be embedded with bias. In this chapter, we talk about computer models. When you have very, very complex systems, sometimes you have to imagine what's going to happen in the system, but your human brain can't hang on to that many parameters. You need a computer to do it, usually a supercomputer, to be able to say, okay, computer, if the CO2 levels continue to rise at this rate, what's the climate going to look like in 75 years? And the computer chugs away using all the information about weather and climate and CO2 that you can put into it. And then it goes, in 75 years, this is what's going to happen. So it can do a lot of stuff that a human can't do. But it is limited by what you tell it about what you're asking. Like in climate, we know that clouds have an effect on light reflecting and holding heat in, but clouds are so transitory that we don't really know how to tell a climate computer how to factor them in over years and years and years. So that computer model basically exists like clouds did not exist. Also, even a supercomputer needs to have kind of a simplified grid that it's tracking over a simplified timeline. So it may be a block the size of New Jersey has the same weather for like a month, and it affects the blocks around it, and then you change it and it goes another month. So there are limitations on these models. What does that do for the evidence when it says this is what's going to happen in 75 years? How good is that evidence? The next one, very first piece of evidence that led to the idea of what took out the dinosaurs. When I was a kid, everybody figured it was just the world got colder. There was a fella, paleontologist, who was an expert in late Cretaceous fossils, the very last era of the dinosaurs. And when he went looking for fossils, he knew where to find the late Cretaceous because there was a thin, kind of reddish layer. Too thin to have any fossils in it, but it was a marker. Below that was the Cretaceous, above that, no dinosaurs. And at one point he said to himself, I wonder if this layer means anything. Because I'm a fossil guy, there's no fossils in it. I'm not a chemist, but maybe there's something in the layer chemically that isn't like useful. So he carved out some of these and he sent it off to a geochemist. And the chemist came back and went, well, it's sediments, sedimentary rock. But there is an element in that layer that's not in the layers above or the layers below, and that's actually an unusual thing to find. it's iridium. And the paleontologist went, so, where do you find iridium? The guy goes, well, really, really deep in the earth, because it's a heavy element that settled like the iron settled when the earth was molten. If you're looking for iridium not deep in the earth, you look in meteors. Meteors are, iridium rich, like the earth was when it started. That all sank, but meteors happen. Or asteroids, presumably, big meteors. That was the first piece of evidence that led to the idea that the dinosaurs were wiped out by a big asteroid impact. How good is that as a piece of evidence? A few years ago, article talking about HIV/AIDS. HIV/AIDS, the first cases arose in Western Africa in the early 1960s. And what the article was claiming was that in the few years before this, there was a big, massive polio vaccination campaign in that part of Western Africa. And the article was claiming that something in the vaccine was the producer of HIV, some contaminant or something, they didn't know what. But they were blaming HIV on this polio vaccine. How good is that as evidence? There is a classic thing that they say in science, which is correlation is not causation. Just because two things seem to appear together doesn't mean one is making the other one happen. Now, this is not a big surprise. The people that made the vaccine were not terribly happy with this hypothesis. And so they came forth and they said, we got records. That polio vaccination campaign in Western Africa, that batch did not just go to Western Africa. A large portion of that batch of vaccine went to Poland. And there was no HIV breakout in Poland in the 1960s. There was no HIV in Poland until it spread there from the rest of the world 30 years later. So when you add in that piece of evidence, how good is the evidence that it was the vaccine that produced HIV? Sticking with HIV, we try to figure out where it did come from. There's SIV, simian immunodeficiency virus. And when we compare the DNA sequences in the two viruses, they are in the mid-90 percentile range of the same. And we use that as evidence that they share an ancestor not too far back on their family tree. That the DNA has not had that much chance to change since that common ancestor that would have had the starting DNA. How good is that evidence connecting HIV to SIV? Now you've got basically the same evidence when you compare human DNA to chimpanzee DNA. In the mid-90 percentile range, it varies depending on the study, but about the same. How good is that evidence that chimps and humans share a common ancestor not that far back down the family tree? Sometimes what people will allow for viruses, they don't necessarily allow for, great-grandma. So there was a class action suit filed back in the 80s on the behalf of women who had gotten silicone breast implants. Another one of these deals where a couple of women who knew each other were having these immune system problems, and they went to a lawyer, and he did put a class action suit together. We found a whole bunch of women, and they go to court and say 8% of the women getting these breast implants were getting these various immune system deficiencies. That's a decent chunk. But how good is the evidence that the implants are connected to the immune system problem? What a number down. Well, with something like a body implant, at the time the silicone breast implants were developed, it was so new that there was no regulatory oversight on it. They didn't need to be cleared by regulations or anything. But by the point that the trial was going on, the FDA did control these sorts of things, and they said, well, we got to look into this. And so they did a study comparing women who had gotten silicone breast implants with women who hadn't, tried to match them for age and ethnicity and socioeconomic status. You just try to set your comparison groups up. It's pretty good comparison. And what they found was, in the control group, the comparison group, they ran about 8% of these immune system deficiencies. And when you put that in, how good is the evidence that the implants are causing the problem? The one thing I didn't tell you, because I thought it would bias your number. The company that made the implants paid a huge settlement to the class action suit. And you go, well, that must mean that they knew there was a problem. The assumption is they did not want to sit in front of a jury and go, well, we weren't required to test them for safety, so we never did test them for safety, because they knew that they would get really hammered if they did that. But it turns out that it wasn't really cost effective. Okay, open the next 2 pages so you can see both pages. And grab your last handout.